So you've probably seen them when you've been out shopping at the sporting goods stores or home improvement stores, places like that. You'll see these, or camping stores. You'll see these solar chargers, and they're usually priced, as I've seen them, around $1,500. And I built a solar system for around $300, about a fifth of that price. And theirs, I don't think theirs comes with the solar panel that you'd have to buy extra. Mine, I included the panel for that price. And I don't like wasting $1,200 if I don't need to, and I don't think you do either, so I figured you might like this. I'm going to explain how to plan and assemble your very own custom solar charger for rock bottom prices that will meet your custom needs. So when we get started, we're going to need to understand certain components, certain basic parts of a solar charger. One of them is the photovoltaic or solar panel that converts the sun's energy into electrical energy. This is usually direct current, and it is usually 12 volts, but you need to make sure it's almost always direct current from one of those things. But you need to make sure of that, and make sure that that is compatible with your charge controller. Something else to be aware of with the photovoltaic solar panels is they're generally not flexible unless they've been advertised to be flexible. So make sure you don't bend them or anything like that, because you will ruin it. The battery is one of the key components. That could be any type of, well, once again, you need to make sure it is compatible with the charge controller. But almost any type of 12-volt battery will do the trick. You can get ones that are special for solar, lead acid, or lithium ion, any number of those types of batteries that you can get. You need a rechargeable battery, and that battery needs to meet the chemistry requirements of the charge controller. The battery and the charge controller are the two of the most sensitive parts of this. The battery, you do not want to leave it out on the ground. If you set it on the ground, you want to make sure that there's something insulated under it, a good board or something like that, not a metal shelf that's connected with the ground. You want to make sure it's not on the ground, not electrically connected to the ground, because that will kill your battery. And then make sure that you don't short the terminals of your battery. Make sure you don't overdrain or overcharge your battery. Those are things to take care of on your battery, but make sure it's the right voltage for what your charge controller is going to be capable of handling. Now, your cables is not too sensitive, but you do want to make sure that they are the right connectors to connect, long enough to be able to connect, not so long that you're dealing with voltage drop. So preferably the right length. I generally shoot for about 6 to 12 inches longer than is necessary to make the connection. But if they're longer than that, I just wouldn't try and have tons of them if I can avoid it. I wouldn't try and have tons of length beyond that. If they're a little bit longer than that, I don't think it's a big problem. But too much length will create voltage drop, and make sure they are the right thickness to handle the power that you're planning on running through them. Now, your charge controller is very sensitive on that. It needs to be the right, you need to make sure that it is able to handle the power produced by the panels, and it's able to handle the power that you're going to draw directly off the charge controller as well. It has the right wattage for that. It is the right voltage, and it's compatible with the battery's chemistry. So if you're using a lead acid battery, make sure your charge controller is compatible with lead acid. If you're using a lithium ion, make sure that you're using a charge controller that is capable of handling a lithium-ion battery. And then the case. The case is, I would prefer to have an insulated material. Metal is conductive. If you don't properly secure your battery, it could fall over inside there, and it could slide up against against your metal frame, short out its battery terminals. When you short out a battery, it can ruin the battery, it can catch fire, it could even explode. It could catch everything else around it on fire, and it could spill corrosive acid. So, you do want to make sure it's secured, it's not going to spill, it's not going to tip over, but I also prefer a case that's not conductive for that. And if it's made out of wood, then it will be conductive when wet. If this is designed to go outside and be used outside in the woods and all that, during a rainstorm, if it really gets saturated, a wood case could get wet. But if your battery's secured really well and everything's wired in there really well, it's not as big of a deal. Mainly it needs to be a strong enough structure to be able to handle the weight of whatever components you're going to load on into there. You can go with multiple panels and batteries and make it bigger, but this one here we're just going to stick with 1 and 1 just to make it simple for this initial appearance. Alright, so those are certain other components as well. You can have a like a USB cell phone charger connected to it, an inverter. So a USB cell phone charger would provide access to the lower voltage, like say for charging a phone or a USB power bank or other USB devices. You could charge off of that with a USB charger, and then you could also run an inverter that's able to run household wall power. So you can run those devices as well. But make sure that it's not going to over drain your batteries. If you drain the batteries too quickly as well, they can heat up and catch fire or explode as well. So you don't want to drain them too far, don't want to drain them too fast. So that's another thing too that you could have in here, fuses and something else that would be able to prevent it from over draining the battery, an over drain prevention device for your battery. But that's going to depend on how exactly you want to hook this thing up. If you just need 12 volt power to run a few things, you got everything set up to where it can run on 12 volt. Maybe you don't need any of these extra things that I mentioned here that aren't on the slide. So let's get to the diagram and explain how we connect this stuff. The charge controller is very important. You read the manual. It's going to matter which one of these you hook up, if it's going to be the battery or the solar panel first. Some say the battery and some say the solar panel. Read the manual for your charge controller, because you may ruin your charge controller or may cause another hazardous situation if you don't mind the manual on that. But you're going to hook up the solar panel array, whatever solar panel or panels you have, to that charge controller, and you're going to hook up your battery array, whatever battery or batteries that you have, to that charge controller. Creating those arrays, that would be a different video for a different time. But that's where you would connect them, is to each other there. And then out, you're also got another port on the charge controller that is for the load, that you can run something right off of. But make sure that your total panels, like say if these are 100 watt panels, which are very common, if this is a 100 watt charge controller, you don't want more than one panel hooked in here. If this is a 500 watt, then you can have up to 5 panels hooked in here. Also, make sure that you're not draining over that wattage out in your load. If this is a 100 watt charge controller, not more than 100 watts total out that load port. If it's 500 watt, you can drain up to 500 watt. If you've got a bigger one, you can drain more. But that charge controller, that's an important thing. But the main function of this charge controller is to protect the battery. If these solar panels are not generating enough electricity, they will oftentimes try to drain the battery. They become resistors, they become loads. A lot of power generating capabilities are like that. And you don't necessarily need to use solar either. You could also use these a lot of times with some other type of generation as well and protect that battery in a similar fashion. But it protects that battery from back draining, from having it run these resistors as loads and killing your battery without doing anything. So it prevents that backdraw. It also prevents your battery from being drained too fast or too far. It prevents overcharging of the battery. It'll stop charging once it's overcharged, once it gets to the peak charge for that battery. And that's why these voltages that it's going to use are different for the battery chemistries. So make sure that your charge controller is the right chemistry for your battery. I can't stress that enough. If you're using the wrong charge controller, you might as well not use one at all. You might as well just hook them up directly. I mean, it'd probably be better off. So if you needed to run more than whatever your charge controller handles, let's just say 500 watts for the rest of this video. If you wanted to charge, let's say this inverter here is, let's say it's a 200 watt inverter. Your radio is, let's say that's a 50 watt transmitter. Therefore, let's say it's 100 watts. And your cell phone charger is, say, 50 watts. You'd have no problem running all this off of the 500 watt port. But if this is a bigger inverter, let's say you've got 400 watt inverter, you don't want to run all this at the same time. So you can run the radio and the USB charger off that port. And this is real good because on this port, this should be fused, but you want to double check that. And it should be protected from overdrawing the battery, which means you don't have to worry as much. Just make sure that the wattage is okay, that you're not going to burn out your charge controller with drawing too many watts. And as long as that's the case, then you're good to hook up to that. And you don't have to worry about overdraining your battery or killing your batteries in some other way with these devices. Your charge controller will do the protection. But if you have more being drawn off of here, like that inverter is extra powerful, you may need to hook that up directly to the battery terminals. In that case, you need to run your own fuse and your own battery charge protection. Make sure it won't overdrain that battery, that it will shut off before it overdrains it. But here you can get your different voltages from that. Let's say this is a 12 volt system. Then you could hook up the 12 volt radio directly to it. If it's not 12 volt, then you'll need to run a transformer or something like that to get it to that voltage for that. Your inverter, it needs to hook up to this voltage as well, or have some other transformer. But once you got your 12 volt, then you can hook up an inverter and get to the 110, the wall power stuff. There you can hook up battery chargers, laptops, PCs, all your household stuff. Just make sure you're not drawing more than the inverter is allowed to take. Your USB charger, you can plug that in and charge USB devices. And you can plug in regular vehicle vacuums or vehicle radios or whatever you want to, 12 volt lighting, whatever it be, directly without any of these conversions. But you have these options to be able to hook all this up once you get that basic charge controller and battery array in there, and then figure out if you need to hook up anything that needs to go directly to the battery. In that case, once again, fuse it and make sure it has some type of an arrestor to make sure it will not overdrain the battery and overdrain protection. Thank you for watching.